Today we're going to take a little break from some proofs, and we're going to look specifically at isosceles and equilateral triangles instead of just regular scalene triangles. Now, I said we're going to take a break from proofs. Well, we got to prove something, and then we're going to use it over and over. So this is the proof of the isosceles triangle theorem. Begin with an isosceles triangle. Got it. Got a picture of it. XY is congruent to XZ. They've got that marked for us. That's what makes it isosceles. You have two legs that are congruent. You're going to draw in this, it's called an auxiliary line, just an extra line. You're not changing the picture, just drawing in an extra line that's going to help us. And that XB line is the bisector of that angle up there. Now, if you do that, if you draw that in there, it creates angle 1 and 2. And we kind of do that just so that we can use those two angles. So what I'm given for this proof is that the two sides are the same, and I got an angle bisector. What I want to show is that angle Y is congruent to angle Z, right here. These two angles have to be congruent. All right. First step, let's go put it in that given. And they were kind enough to mark the picture with that for us, sort of. They've got the sides marked, but okay, I guess it's only one congruence. But if XB bisects that angle, what does that mean to you? I hope you're thinking that angle 1 would have to be congruent to angle 2, because that's what bisecting means. Cut it into two equal parts. And because that's what it means, that's the definition of a bisector. Okay, I totally lied when I said we weren't doing proofs today. So we're doing the same old that we did yesterday. I'm going to prove these two triangles by pulling in that extra line in there. I'm able to look at this as two triangles, and I'm going to do the same thing I've been doing. I got to get my three congruences. Right now I have two congruences, but I see that the two triangles share a side, so I'm going to go XB congruent to XB by reflexive. As soon as you have three congruences, let's see what we've got. These angles I showed were congruent, and then this side is, so I got two sets of sides and an angle, and that angle appears to be the included angle. As you wrap around, it's side and then an angle and then a side. Side, angle, side. Those two triangles are congruent. Are you writing little? I should have mentioned write little. Triangle XYB congruent to triangle XZB, and that would be by side, angle, side. And if the triangles are congruent, then I know from yesterday that all their parts are. Specifically, angle Y would be congruent to angle Z. That's what I'm trying to show. That's CPCTC. But more importantly, what I was able to show here by doing that proof, I was shown that if I have an isosceles triangle, right here, where you have these two sides the same, you can always work through it like I did and find out that these two angles down here, those are called the base angles. If the two sides are congruent, then the two base angles are congruent. That is the isosceles triangle theorem. If you have an isosceles triangle, the two sides are congruent, that's the definition, but their base angles are also going to be congruent. And so I've written it, if you have two sides the same, then the base angles are the same. That's what we've got. Isosceles triangle theorem, that's what we would write in a proof right there as a reason. And it actually works the other way too. Remember, the converse means you can switch the if and the then. So instead of saying if the sides are congruent, I can say if you have their base angles congruent, then the sides would also be congruent. I can switch the if and then. That's the converse of the isosceles triangle theorem. And then there were a few other theorems. They're not near as common as the isosceles triangle theorem, but I thought I'd go over them real quick. If you happen to know that these two sides are the same, so that you got yourself an isosceles triangle, and you know that you've got this angle bisector in here, because these two angles are the same, that angle bisector is actually more than just an angle bisector. It actually drops down and is perpendicular, so it's an altitude to that triangle. It also comes down as it does that, and it splits it into two equal parts, so it hits the midpoint right there. All right, those are some special features. That only works in an isosceles triangle. All right, let's move on to equilateral triangles. A triangle is equilateral if and only if it is equiangular. If and only if, remember from Chapter 2, means that you can write it either way. A triangle is equilateral if it's equiangular, or I could say if a triangle is equiangular, then it's equilateral. If the sides are all the same, then the angles are all the same. Or if you knew all the angles were the same, then you'd know all the sides are the same. All right. Then I'm going to spend some time on some constructions. All right. So get your construction tools out, and let's construct an equilateral triangle by making the legs congruent. All right, we've done this. You just have to pick a leg length. I don't even care what it is. I probably, if I were to do this, I would just draw a random line. I would put the point of my compass here, open it up, and just pick some random measurement here and make an arc. And that right there is what I'm going to want all my side lengths to be. So don't move your compass. Once you make that arc, you want to keep that measurement. And you're going to come up here, keep your point right here, and you extend that, and you make a big arc up here. Then you move your compass, and you put the point of the compass here, have not changed the size of it, and then you put an arc up there. What you've forced is all the sides to be the same length as that original one, and then you can draw in the side lengths here, and you've got yourself an equilateral triangle. That's not too bad for freehanding. You, of course, have it even better because yours is constructed. Now let's look at, tie some things together. We've talked about the sum of the angles in a triangle. What do they always add up to? All the angles, any triangle, adds up to 180. In an equilateral triangle, we just said all the angles are congruent. So that leads us to then determine that if you have all three angles in an equilateral triangle are the same and they got to add up to 180, then they are all 60 degrees. Now we're going to use that to do some constructions. We can use the equilateral triangle construction that we just did. We just created an equilateral triangle. We're going to use that to make a 60-degree angle. I can start doing some things and having specific, we've done like 90 degrees and we've done 45. Now I have a 60-degree angle construction that I can do. This says, construct an isosceles triangle by making the legs congruent. Okay, so random length of line right here. Now, it really doesn't even matter. This is going to be like the base of my triangle, that it's the one side that doesn't match. So I'm probably going to just say, all right, let's put a dot there, and let's put a dot. I don't know. I guess we could put a dot right here. Let's just use the end of it. Now, I don't really want this to be an equilateral triangle. I just want it to stay isosceles. I just want two sides the same. So I'm going to move my compass and mark it off so that it's not exactly the same length as this given segment I have. I'm going to make it a little bit shorter. Then I'm going to put my point here, and when I say shorter, it doesn't, well, it needs to be out here someplace, so you don't really even need to put this arc, but I'm just showing you that's how big I would make my compass maybe. Make it shorter than what this line is, but not crazy short. Now, once I have that measurement with my compass, I'm just going to come up here and create an arc. Then I'm going to put my point on the other end and create the same arc. And what I've got then is this X that I can draw this in, and here's going to be my equilateral triangle. I'm sorry, my isosceles triangle. I make these two legs be the same and purposely make this other side be different. There's my isosceles triangle. Now, if I have made this correctly and these two legs are the same, I should be able to confirm that the angle measures are also congruent. So ideally, if I have a protractor, I can measure this angle and measure this angle, and they're going to be the same. Since the legs are the same, then the angles are the same. That's Isosceles Triangle theorem. Now I'm going to try to do the converse of the isosceles triangle. Instead of making my two legs the same, I'm going to make my two angles the same. I'm going to start off, and I'm just going to draw a random length for my bottom, for my base. There it is. And then instead of making the other sides the same, I'm going to make some random angle measurement here. So I'm going to just draw this plenty long. I don't really know how long it's supposed to be. I'm just going to make it plenty long. Now what I want to do is I want to create an angle over here that matches this angle here. I need to copy this angle over to here. To copy an angle, you're going to put an arc through here, random measurement, but then you're going to come over here and put your point there and make the same random arc. These arcs might end up intersecting, I don't know. Now, once I've made those two arcs, I'm going to put the point of my compass right here, and I'm going to measure how wide that arc is right there. Put an arc through there right where it hits, and I want to copy that width over to this side. So now put the point of my compass here and copy that width right there. Last step then would be to draw in this from the left through the X on up, and what I did is I made these two angles congruent, and then I should be able to confirm these legs here should also be congruent. That's the converse of the isosceles triangle theorem. If the angles are congruent, then these sides should also be congruent. All right, that's all we've got today. Should be a little bit easier, not as many proofs. Good luck.